The literature on diet and cancer is mind-boggling. Thousands and thousands of papers of all kinds. For example, in this case, about chewing tobacco or chewing betel nuts. Well, I don't think we're surprised about tobacco, and we know that smoking kills. Tobacco smoke contains a large variety of carcinogens. But I think many people may not have heard of betel nuts. It's quite common in Asia to chew betel nuts, and they contain a number of compounds that can initiate cancer in the mouth. So there are all kinds of substances in our environment that have been looked at that can trigger cancer. We also know that obesity is a real problem. Statistical evidence indicates that cancers of the esophagus, the colon, the rectum, the breast, uterus, and kidney are all linked to being overweight. But of course, we know that overweight is not desirable. We've already looked at the relationship between overweight and diabetes, overweight and heart disease. We've also referred before in the past to some of the risk of drinking alcohol. Alcohol is linked with cancers of the mouth, the larynx, the esophagus, liver, and the breast. How much? Because, of course, it's only the dose makes the poison. Well, in the case of breast cancer, this is where it becomes quite worrisome because what the studies show is that even small amounts of alcohol are linked to small increases in risk of cancer. Of course, we also have to take into account that alcohol provides a great deal of pleasure to people, and having that glass of wine with the meal is something that many look forward to. So certainly no one is suggesting that we should cut out all alcohol, but moderation. The question is, what does moderation really mean? And I think most experts would agree that 1 glass a day is not a big problem, but with 2 glasses a day, you already start to look at an increase in breast cancer rates. But much of this data comes from associations, and associations never really prove cause and effect. Let me give you an example. If we take a look at the intake of cereals, of grains, for example, in Japan and the UK, it has been slightly decreasing. And at the same time, meat consumption has increased significantly in Japan. Japan used to be pretty much a vegetarian society or fish-oriented society, but eating a lot more meat. And look at the results in Japan in terms of colorectal cancer. It seems to go up in parallel with meat consumption. Well, what does that really mean? It means that we should look further into it. It doesn't mean that we can conclude that eating meat causes colorectal cancer. However, when we look at the science, there is reason to investigate it in depth because meat does contain a variety of compounds that are known to cause cancer, especially if the meat is cooked at a high temperature. There are compounds in there called heterocyclic amines, and those are carcinogenic, and so is benzopyrene. Benzopyrene is also found in tobacco smoke, indeed so are heterocyclic amines. These are some of the compounds that are responsible for lung cancer increase in smokers. We also have issue with prepared meats like cold cuts, salami, etc. And here too, there are associations between eating significant amounts of these processed meats and increased risk of colorectal cancer. So that's an association. It's not cause and effect, but it causes us to think, what could this be due to? Is it the heterocyclic aromatic amines? Is it the polycyclic hydrocarbons? Preserved meats contain nitrites, and nitrites in the body can form nitrosamines, and nitrosamines are carcinogens. Iron is an oxidizing agent, and it can lead to various reactions in the body that can trigger cancer. And we look at the scientific literature, and unfortunately, we do find a number of studies that show that increased intake of meat is associated with increased risk of cancer. And this particular one, which is a very significant study by the School of Public Health at Harvard, And they estimate that we could save a significant number of cancer cases just by cutting down meat to about half a serving a day. Red meat is what we are talking about. But again, I hasten to add that not every study shows this. If we look at another study, again carried out by School of Public Health at Harvard, which is the Nurses' Health Study, they looked at 90,000 nurses over the age of 18. They unveiled 4,000 cases of breast cancer, and in this case there was no association with meat consumption, but we're looking at one specific kind of cancer here. But what they did find was that the risk increased with total calorie consumption. Another little warning about all of these studies, though, is that they are mostly recall studies where people fill out questionnaires where they are asked about what they had eaten, generally over the past year or maybe even over the past 2 years. And we also know that these are not very accurate questionnaire answers. People very often will say what they think that the questioner would want to hear, because most people have some idea of what is eating healthy and what isn't. And they will downplay the eating of so-called unhealthy foods and upplay the ones that they think are healthy. So there really need to be better ways of finding data about cancer. And there are better ways. I mean, there are all kinds of studies that are published in the peer-reviewed literature. And we've referred to the type of studies before. These are the cohort studies, the case control studies, the in vivo studies, meaning in animals, in vitro, meaning laboratory experiments, and intervention trials. Those are the most important ones. Those are the ones where we take two populations, give one whatever substance we believe is going to have an effect on cancer in terms of prevention, not give it to the other group, give them a placebo instead, follow the two groups to see what happens. Those are the most meaningful studies, but those, of course, are also the most difficult to carry out. So I'll give you some examples of each of these, and we'll critique them and see overall where the information leads us. Let's start with one that we just looked at earlier, which is the Nurses' Health Study. This is something that we refer to as a cohort study because we're looking at one group of subjects that have been followed for years. And this started way back in 1976 with over 121,000 nurses. And of course, some of them have dropped out of the study. Some obviously have died. But anyway, after 10 years, it turned out that those with the highest consumption of carotenoid-containing foods had a significantly reduced risk of lung cancer. But what do we do with data like that? Because after all, do we really know that the effect was due to the increased consumption of carotenoids? Because when we look at the data, it also turns out that that increased consumption of carotenoid-containing fruits and vegetables was paralleled by a decreased consumption of meat. Because, of course, we will only eat a certain amount of calories every day. So if you increase one type of food, you're going to decrease something else. So is it the decrease in meat consumption or the increase in vegetables that is responsible for the effect? And we can't glean that information from this kind of a cohort study. Somewhat more informative is the case control study, such as this one here about pancreatic cancer, where you select a group of patients who will suffer from a certain disease, in this case pancreatic cancer, and you match them against controls who come from the same sort of socioeconomic lifestyle, roughly the same age, and you try to match them across the board, the only difference being that the controls don't have pancreatic cancer, and you question them and you investigate what is it that they did differently. Well, in this case control study, for example, patients with the disease were more likely to have consumed more smoked and fried foods and far less raw fruits and vegetables. And that, of course, is interesting. And it also has scientific plausibility, because when you consider something like smoked meat, well, is there some scientific reason that actually can increase the rate of certain cancers? And the answer is yes, because smoked meat, of course, has been treated with smoke. And we know what smoke can do. We know that from cigarettes. Smoke is very, very complex chemically. Here's a list of chemicals that have been isolated from smoke. And some of these are known carcinogens. So it isn't surprising that smoked foods would be associated with an increased risk of cancer. That's kind of painful to us here in Montreal because we are the world headquarters of smoked meat. In fact, the location is on St. Lawrence Boulevard in the city here. It's affectionately called Schwartz's after the original owner, although they spelled their name wrong. It's the emporium of smoked meat. It's delicious, but you don't want to eat it too often. And when you go there, you never have a smoked meat sandwich without having French fries. And that just increases the nutritional complexity because when you fry potatoes, you introduce a chemical called 4-hydroxytrans-2-noninal. This compound forms when polyunsaturated fats are heated. It is the high temperature that causes the fats to break down, and one of the breakdown products is the 4-hydroxytrans-2-noninal. And this is linked with heart disease, with stroke, Parkinson's, Alzheimer's, liver problems, and unfortunately, cancer. It's a cancer-causing agent. Now, what do we do to solve this problem? We could take those French fries and fry them in beef tallow. That's saturated fat. You're not going to form any of the noninal from that, but then you're trading in one problem for another because, of course, we've discussed previously all of the problems associated with saturated fats, and they're linked to heart disease, although that link is not quite as strong as we used to think that it is, but still, it's better not to cook in beef tallow. So what's a happy medium? Well, how about peanut oil or olive oil? These are monounsaturated fats. They don't break down easily upon exposure to heat, and they don't form the hydroxynoninal. Well, that hydroxynoninal is something that we refer to as a carcinogen, meaning that it's a compound that causes cancer. We've long known that carcinogens exist. If we have to kind of mark who first noted this, it would have been Percival Pott, a surgeon who lived way back in the 18th century. He was the first one to note that chimney sweeps suffered from something called chimney sweeps carcinoma. It was a cancer of the scrotum, and it was due to the accumulation of soot. And of course, they were climbing up and down roofs and cleaning the chimneys and not washing themselves properly. And the accumulation of soot was linked to cancer of the scrotum. In retrospect, of course, this is not surprising to us because we just looked at the number of potential carcinogens that are present in smoke. Unfortunately, they're also present in barbecued foods, which we enjoy so much. So smoke is really a problem. It contains carcinogens. Now, what is this term carcinogen? I mean, I've been bandying this about almost recklessly without really defining it. A carcinogen is really a substance that causes some sort of cancer in some animal at some dose. It does not mean that it is known to be a human carcinogen. It just means that this is a substance that has the potential of causing cancer, not that it is known to cause cancer under normal conditions. For example, every food that you're looking at in this picture has some sort of carcinogen in it. There's paculin in the apple, there's safrole in the black pepper, benzopyrenes in the toasted bread, and of course ethanol in the wine. Each of these, if given in, albeit high doses, to test animals, can trigger cancer, and therefore it is called a carcinogen. Coffee is a great example. It contains a whole slew of carcinogens, all the way from acrylamide to furfural. That's a lot of carcinogens in coffee. However, we know that coffee itself does not cause cancer. How do we know this? Because if it would, that would have been very apparent in epidemiological studies. So here we have the presence of compounds that in high doses would cause cancer in test animals, but in the small amounts that we find them in coffee, basically they're inconsequential. It's the small amounts, and also the fact that coffee contains other compounds called antioxidants, which can mitigate the effect of the carcinogens. But there's no question that the carcinogens are there. Furfural, one of the compounds that I noted, is found in all kinds of coffee. How do we know it's a carcinogen? Because we can expose rodents to it. We can feed the rodents this carcinogen and find that if you give it at a dose of about 200 milligrams per kilogram of body weight, you can trigger cancer. Well, we of course don't go out of our way to purposefully eat furfural, but it's there in coffee, it's there in other foods as well. It's there in grain, for example. So if we take the grain and bake it into bread, should we be labeling that bread as something that contains carcinogens? Well, I think common sense tells us no, we don't need to label it. Why? Because we need to look at amounts. And the amount of furfural that is in there is measured in trace quantities. And you'd have to eat about 6,000 loaves of bread to match the dose that causes cancer in the rodent. So just because a carcinogen is present doesn't mean that we need to be worried about it. If we were going to consume 6,000 loaves of bread, there would be other things to worry about, including acrylamide. And this makes for an interesting story.